Hello there. Let's see how the music sounds. Let's see how music sounds. Let's see how music sounds. Yeah, should be right. Is the music too loud? Good. Good. If the music oh, and Google Meets you cannot hear it actually. Yeah, you have to go to the YouTube stream. Yeah, try going there and just help me see if it's too loud or not. I want it to be barely noticeable. Yeah. Yeah, I turned it down a bit more. I don't want it to be a distraction. Just barely noticeable. Yeah, so welcome on day 3 of week 3 and the second session, the 3 sessions, live coding sessions. And I don't think we'll be waiting too much. We'll just get started. Yeah, I know my voice is louder because I set it up that way, but I still want, like, in the moments of silence, I want it to not be audible at all. Or very barely noticeable. All right. So again, welcome to the second live coding session. And let's see what we've got again. So we can kill players we can kill enemies and enemies can kill us with the reg. And today, let's see, maybe we make the wave system where you can kill the enemies, the next wave comes in and the next wave, and when there's when the last wave comes in, you see a a level complete event, a level complete text. And that should be it for today. And when we have the wave system, then yeah, we'll see. So let's look at our game design document, which is the base, a knowledge base. Yeah, so we have the player, which is 10 HP, and we've already done it. So we won't be making like a detailed 3D spaceship. That would be like a polish thing on the polishing side. So an egg would have an infinite HP and the impact damage 32. Okay. Yeah, it's infinite, and I mean we don't have to put like a health bar and give it like a very large number, a very large amount of health. We just make it. We just don't give it a health component. Weapons or enemy weapons. I mean, we can just add this as the enemy projectile, I guess. Makes more sense. Projectile. Egg projectile, and the egg projectile doesn't have a health. Base damage 100, and let's make it 32 as per the design document. Oops, we have to exit. And yeah, we can mark this as done. And we have our duck. And good, so let's like create our should we create it now or later? We'll create it later because it's more important to have a wave system instead of having this is more of a detail like yellow, green, blue, whatever. Player fires projectiles automatically. Should we do that? No, I don't like this. Fires projectiles. I have this power to change the requirements on the fly, but you wouldn't usually have that luxury. Okay, it doesn't say what damage. Well, let's say like chicken health is 2. Yeah, so we have our chicken, which has a health of 2. And let's say I mean, let's say we're making like the yellow chicken. Or let's make the green chicken, because we also have the egg, so let's just make it throw an egg once per minute, right? So we'll have it will have an HP of 30. So we're making it directly like this. Green chicken and an HP of 30, right? $30, $30. And let's also make the material for the chicken. So the chicken has this visual, which is the default one, but let's change it. Material. And let's just set a very simple shader for it. I mean, let's keep it the standard one. It's just simple. Green chicken. So these are green chicken. And yeah, we'll have to create that egg throwing. So we'll just be coloring this as completed. So HP 30, right? And our laser will have a damage of, I don't know, let's say 15. That's our base damage. I mean, let's give it like 4 because it's an area bullet. So we'll see how that works. Yeah, this is like the game designer's job to balance this out. And it's an iterative process, so you with the game designers and your testers work around it and find the right results, right numbers. And you will use a lot of Google spreadsheets or Microsoft Excel stuff to handle these things. But yeah, let's keep it simple. So the laser bullet will have 15 damage. So let's go to laser projectile. Damage 15. Good. And we've made it, so it's already done. We'll do this. We'll try to do it today. Basically, we'll have a weapon upgrade, which means it will double our weapon's size, and it will just, let's say, like, it will increase our weapon size and damage by 30%. And you can have like maybe 3 upgrades. Yeah, this is what we'll be doing. And level 1 has 1, 2, 3, 4, 3 waves and a boss. And we'll have 50 yellow duck, 50 green duck, this and this overgrown duck, and we'll be only doing it. We'll be only doing green ducks, or I don't know, maybe. Yeah, maybe we'll also create yellow, green, blue because it's very easy. Yeah, we'll be doing that. Okay. End screen, maybe not now. Slowly scrolling. Oh, we have to do this. This is very simple. I love particle systems. I really love them. Yeah, soundtrack for bosses. And we can even generate one. You know what? We'll generate one. Yeah, we'll generate one. And there's a cool open source tool for that. And it's called Music Gen. Music Gen. And you can download this, and where is it? You can download this and run it locally. It's amazing. It's not perfect. It's like suno.ai. You can create a song about anything. It's amazing. I mean, you can give it lyrics and it's like out of this world. It's amazing. Probably after a few months there will be an even better model for music. So yeah, I mean, this stuff changes so fast, which is amazing. Just embrace it. Don't run away from it. Just be happy and embrace it, because yeah, it's amazing. 1 second, I should change. I should again check my and embrace it, because yeah, it's amazing. 1 second, I should change. I should again check my. 1 second, embrace it, because yeah, it's amazing. 1 second, I should change. I should again check my. Yeah, I guess the music. I just want to make sure the music is not distracting. The background one. Okay, good. Let's create. Yeah, I guess the music. I just want to make sure the. Shut up, man. Um. Space. Soundtrack. Space. Shooter game. Low key. Relaxed. What else? Soundtrack for a space shooter game, low key, relaxed. Let's see, what else should the soundtrack have? Mysterious. Funny? I don't know. Yeah, let's see what it does. Let's make that particle system. So I think we'll have the same background for all our levels, or not? I mean, we shouldn't. Like, we already have the same skybox. But let's have like each level, let it have this a different particle system. And yeah, it will be far away, and do we have like a 2D particle system? No, but I think we can do it. So these will be the stars, or yeah, moving stars, or moving background. And we'll do it in the shape sphere, mesh, circle, rectangle. Perfect, man. Now we have a rectangle. Scale. Yeah. That's right, man. Actually, it should start from the top of the screen. which means we have to rotate it with the command or alt on Windows. You rotate it to 90 degrees or 180 degrees. Yeah. All right. I mean, we can just look here. So let's make the X scale bigger. Nice. And let's see where's the camera frustum. So the camera is there and the particle system is here. Like, let's make it even higher just to make sure we account for, yeah, like this. And we'll need to duration. I mean, duration can be 50, I don't know. Start lifetime 50. And we can have like a very slow speed. So start speed will be like 1. And we'll need emission to have like this. And we need the size to be start size 0.1. Right. Man, I really love this. Yeah, so it's subtle. Man, I really love this. So let's create like a prefab for it. Small, or let's call it like layer 1. Let's copy it. And we'll move this one. I don't know what happened, but probably stop. Something interesting happened here. Maybe there's a bug in Unity, yeah. So we're seeing it like this. So let's say maybe we create a new scene. We enter this new scene and then we enter again this one. Let's see, do we still see that issue? Looks like, even though in the game we don't see it, I think. Interesting. Let's just create like this again. So surely there's a bug in Unity. So we'll get like transform copy component, the whole component, then paste component values, and then we do copy, but maybe we get the same issue. Paste component values. Yeah, I don't really know what happens. It works in the game screen, but not here. I mean, let's keep it for now like this. So let's like also simulation, scaling, velocity mode. So we don't need them to be considered by the physics system. Yeah. Yeah, I'm really not sure why they appear like that. But you know what? I mean, let's just go on with it. It's just a small thing. So let's just do it like this. Layer 2 would be like theoretically like it would be more to the back. Ah, okay, I just had to change something. So let's say in the back we have the smaller ones. Like, it doesn't really matter how far they are from each other, but it's just good to have them like this, maybe. Oh, okay, this one layer 2 needs to be behind and be smaller, maybe, I don't know, and this one to be like, I mean, the size should be random between two constants. So our size would be between 1 and 0.2, 0.3. And the speed, start speed would be again random between two constants. Between 0.1 and between 3. And we don't even need actually a second layer because that's the power of particle systems. Yeah, I mean, you can even make it like 0.5. And let's probably make it I'd like to see more stars that are smaller and less stars that are bigger, and that's what this random between two curves comes in play. And I think that's how it works. So the way it works, so starting speed, or wait, this is not speed. It's not the speed that I want to change, but the size. Random between two curves. So we want the size to be so you can with the mouse wheel scroll in and then just do it like this. So our size is, where is it, here, and we're starting at 0.3, right, and we're ending at still 0.3, so all of them have 0.3, right? And if I move this thing, wait, I didn't want to do that. I mean, I'm learning this right now, right? So I think this is how it works. So it will be more so there will be more stars that will be smaller and less stars that will be bigger. That's what I want, right? And I think I can write here, so like point, or actually I want them like 2. Let's make speed. Let's make the speed like 5 and 8 so that I can see them faster. And the size 3. So we'll have like, no, like 1. Yeah, this will be the biggest ones. So we will have our stars would be between 0.5 and wait, I don't want to do that. What's that, man? Start size. And I want to move. No. Oh, I think because I didn't select this one. Let's see, can you do it here? No. How does this thing work, man? Clamp, ping pong. I really have to learn how this thing works because I wanted like less things here. Let's see. We smooth, flat. Edit key. So times 0 we have value 1. Oh, I know what this thing means. I think this means that it's not actually the distribution but the time in the simulation space. So first it starts with smaller ones and then with bigger. Okay. This is not what I wanted. Okay, remove. Back to random between two constants. So between 0.1 and 0.7 or something like that. Or yeah, I think 0.7 was good. Right. And rate over time like this. Let's just to see it. Okay. 0.6. Good speed. Again, let's go to the speed. You know what? We'll actually have two particle systems. So these things which are smaller and will be like between 0.1 and 0.3, or you know what, between 0.01 or 0.02, but you can see them in the bigger screen. 0.1, 0.2. Yeah, and let's do it like rate over time, and speed, start speed will be between 1 and 3.2. 0.1 and 2. Yeah, good. So we have one particle system here, which will represent the like stars in the background, and rate over time, let's make that 5. If it's 10. Whoa, this is so... Is this realistic? This is not realistic. This is more realistic. Yeah, I mean, you can stay a whole day here. Yeah. So sides between this, and let's now just copy it. And color, random between two colors. So it will be like that thing, and maybe a slightly red ones, or I don't know, should they be like blue ones also? Two of them. No, there are some blue things, or... Yeah. Good, let's just copy it again. And let's make this one bigger. And this one will have between 0.2 and 0.5. And this one will have a lower emission rate. And the speed has to be higher. Speed. So between... We kind of like the current speed, so let's put it like between 0.5 and 2. And the other guy, let's make it like between 0.1 and 0.5. Right, so yeah, I have to make like more particles available, like maybe 10,000. And they keep disappearing because it's just too many of them. Yeah, they keep disappearing because the speed is too low. Yeah. I don't know how to do it. Maybe it's just too many particle systems. But you know what? Let's just do it like let's. Or I mean, maybe it's too high. So 1, 2, 3, 4, 5. 100,000 particles. Yeah, maybe we just make it like 5. You know what? Let's just make it like 0.3 and 0.9. Or just 1. Yeah, and now this is the first one, and the big one with the bigger stars will have a 1, between 1 and 3. 5, I don't know. So can you see them? Yeah, you see them. And start size would be, this one is between 0.01 and 0.2, and this is between, let's say, yeah, 0.2 and 0.5. Yeah, works well, works good for me. I just like more here, but I don't know how to do it. Yeah, I mean, I really like more here. I can give them, I can have more of them, like more per second, but less. No, it's impossible. Yeah, we have to keep it 5. Yeah. Nice, man. Thank you. Doing fine. I'm immersed here in creating particle systems. I'm trying to I'm trying to wrap the particle system part. Yeah, I think this works. Yeah, I think the starting speed has to vary a bit more. Between 0.1 and 3, and this is between 0.3 and 5. Or I like this. And we get, if we select both of them. Yeah, works for me. And we can select both of them and change some things here if you want. Yeah, some of them still disappear at some point. But it's fine, it's fine. This is our moving background. Let's just add it here. Base, should add it to base. Yeah. Good, so we've made the background. Scrolling background showing stars, galaxies. Yeah, and let's do these things, which is it's very simple to do. So we have a green duck. Let's make the yellow duck and a blue duck. So entities. The yellow one has an HP of 10. Enemy. Should we separate them in folders? Kind of makes sense. But let's keep them like this for now. So we have like a green chicken. Let's make yellow chicken. Red. It was a red one, that one? No, yellow, green, blue. Blue chicken. And we just change this thing for now. Like this is the simplest way. Having a blue chicken. And we have a yellow chicken. Okay. Let's create them. So we have just the green chicken, which is a base. Everything is base. And we just copy and paste it. Yellow chicken. And the yellow chicken has a health of 10. Starting health 10 and maximum health 10. I mean, this should be just maximum health. Because it starts with... It always starts with maximum health. I mean, you can have something that grows in health afterwards, but... You know what? Let's keep it simpler. Like, let's not over-prepare for something we don't know we will have. So, no starting health. The health, starting health would be the maximum health. Perfect, I like that. Good. Yellow chicken gets the yellow chicken material on its visual thing. Or we can just do it like this. Bam. Now let's copy it again and we'll get the blue chicken, which gets the blue material and it has a health of 80 and it drops eggs. Okay, so we've done this thing, we've done this thing, and we'll be doing egg dropping later, just because making the wave system is more important. It's like thinking broader, right? So we try to have a game, not necessarily have perfect enemies. Good. Let's now think of, so this is a blue chicken. Level 1, wave 1. Let's now just... I mean, actually makes sense. We can just keep them like this. First wave. Level 1, wave 2. I mean, we can just look here. So we have wave 1 discovery phase 50x yellow duck. So let's just have that. Wave 1 would be... I mean, we can just have it like this because we are already in level 1 from here, right? So wave 1 would be 50 yellow chickens. And yeah, you can have like a script that spawns these automatically, but let's keep it simple. Have them like this. I mean, I think I can also like use the grid. So I'm pressing command and I can do it like in grids. And grid visual, increment snapping, move by, I can do this one. So they are, my snapping for the movement is 1. So that when I'm pressing command or alt, I do it by 1 meter. You see, Control C, Control V, move by 1 meter. And I'm holding command or alt on Windows. First time I'm using this thing. I just knew that it had to be somewhere there, right? So we have like 1. It's like 8 of them. 50? Man, that's a lot. 50 yellow duck. It's just a lot. I think you'd have to like have 20 at the top. Yeah, I don't even know if it's all of them. Yeah. Yeah, let's see. I mean, yeah, I cannot fit them in the same screen. So, let's see if I try to move them like this. Yeah, let's see, 50, maybe just, you can see somewhere here that it says how many objects are selected, but I can't see it. I don't know why. 20, right here. 20 objects selected. Okay, let's select only at like 18 on the first row. That's the one, and I think, yeah, you can see them. Good. So we have 18, and then again 18. And if you have again 18, so 18 with 18 is 36. Yeah. And with 18 is a lot. It's something with 4. So it's 54. Yeah. It's 54. Hello there. Yeah, so it's 54, so let's just remove all 4 of them. Like, wait, something I didn't want to happen. So, I don't really like, because this thing happened. I mean, is this doubled? No. Anyway, just remove 4. This ones. You can press command or control on Windows and remove them. And yeah, this is our first wave. 50 yellow chickens. Perfect. Then we have 50 green. Actually, you know, we're doing a duck game. We're doing a duck game, man. Damn. We have to call it base duck. Okay, let's do it. Base duck. Is that all? Nothing? Was that easy? Yeah, and these guys are called chickens, but you know what? Can you rename all of them? You can. Well, it's fine. We just copy. I mean, we cannot copy them actually. Yeah, that's the trick. We need the green chickens here in wave 2. Let's put this as 0, 0, 0. So the green chicken is 0, 0, 0. And let's just, yeah, we just add it here. Or, I mean, let's make it maybe a bit different this time. So we have 5 of them. Oh, wait, I was just copying the wave itself. Okay. So we have 10. And we want to, so again, let's see, here we have 50, right? 50, and again 50 green ones. So 10 like this, and then copy them. Then, I don't know, like this, or like this. And again, 10 like here, and 10 like here. Let's disable this so we cannot see it. And we can just select these things, 10 objects, and let's say 10 like here. Yeah, I don't know. You need a good artist to make these things for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, like a 50. Wait, did I just copy this thing? I don't know. 50. Good, so we've made our second wave. And our third wave is, again, 50 blue ducks. And I don't know, we can make it so that the third wave will instantiate 50 ducks for us in a circle somehow. Or it will instantiate them one by one or something like that. Yeah, it might take some time. We might want to think about that. Let's just create it for now. I mean, let's create it. Let's create like sharp script for level 1 wave 3. And what we'll have, it will have a field for the prefab. It will instantiate the prefab 50 times. So we have a script dedicated for the third wave of level 1, right? So we can do that. Why not? Serialize field. So enemy yeah, unit. So we're thinking like in units, right? And let's say we also do like units per second, or yeah, units per second. Or it should be more like, yeah, units per second, I think. But we have to do it like no, delay between spawning units. Spawn interval. Okay, that's interval. It's the keyword. Spawn interval. Spawn point. And guess what we'll do? We'll be giving it a point, a spawn point, but we will be rotating the spawn point. I mean, that's a lot of functionality there, but let's see if we can make it very simple with a lot of impact. Let's see. So yeah, we can rotate it in an ellipse shape. Yeah, but I mean, we can just have this thing spawn point. Yeah, initial spawn point. But we'll be moving the spawn point, so it will orbitate around a point. That's nice. So initial, I mean, actually, yeah, initial spawn point. Orbit origin. So like the center, spawn point, orbit, center. So around which object should our spawn point rotate around? Yeah, around which object should our spawn point rotate? And spawn point orbit speed. And yeah, let's ask ChatGPT how to make this thing. I mean, I can think about it. You have to use sinus and all that stuff. So let's ask. And max units. Max total units. Like since the beginning of the wave. So please complete please complete this script, which in an orbital shape and moves the spawning point around the spawn center out. And we give it this thing. Current unit count, current orbit angle. I don't think you need the angle. I like it that it preserves the coding style, so it added the underscore. You don't have to put it 0. 0 is the default one. Spawn units. Yeah, you can do it this way, I think. So it's actually you're creating your own update function, so that while whatever, wait for second spawn interval. So after this second, it will again execute this thing. Yeah, I like this. I mean, it has some problems, like if you disable the game object and then re-enable it, like it won't resume its execution. So you have to be careful with that thing. And in the update, move spawn point. So current orbit angle is spawn point orbit speed times delta time. So this is actually the angle speed. Okay. Spawn point orbit angular speed. Yeah. Like orbit. So spawn point orbital orbit angular speed. Let's keep it like that. I mean, I just want to be explicit. So current orbit angle, this one, we get the radians. That's how you like, this is a constant which you get an approximation. So dig from degrees to radian, dig to rad, degrees to radian. You basically multiply your degrees and you get radians, because Unity works with radians, like this function math, the cosine takes radians. Yeah. And I mean, you can try to understand this. If you draw it, it makes sense, but I mean, I don't have time for this, and it's not that important now, unless you're very interested in it. Yeah, we get the current angle, then we get the radians, we get that cosine, so the x is the cosine, and the z, actually, I want the z. The y, because the z has to be like whatever the current position is. Spawn point. Current z position is this. So this. I mean, no, the offset should be like 0f, 0, right? Yeah, 0, because like this is the offset. So the spawn point position is spawn point orbit center position dot the offset times the offset, and this will be like, I think, 1 meter. Yeah, it will be like 1 meter around the spawn point. Yeah. And you know what? let's make them like spawn from the start, and towards the end, like they will start from like a spiral, right? Like a spiral. Okay, okay. So that means that we'll have to like this would be the offset. And let's say the offset will always be between 0 and 1. Yeah, and let's say we do like current and we'll do this thing like each frame will basically in each second we'll be incrementing the spawn position. And the spawn position, spawn point, distance increase per second. So per each second we'll be increasing it by, let's say, 0.2. Let's say like that. And we'll do like, okay, plus per second times how many seconds have passed since the last frame. And the way this thing will work is we have the offset and now we multiply. Yeah, we multiply the offset by the actual distance. So this is like a unit vector, on our imaginary sphere, because cosine gets a value between -1 and 1, and then again this one, and now we or let's just do it. Nice, man. And now we have the spawn point, which we don't really need the spawn point. We just could have just done like, I don't know, we can set up just a vector tree and use that vector tree here, but just keep it like that. Maybe we'll uh, have like a particle system in our spawn point. I don't know. Maybe we're doing it like too detailed maybe. Good. I just do it like this. Good. That's like this just to separate them a bit. Yeah, and now it's a circle, but I would like it to be an oval shape like this. And in order for it to be an oval, let's ask ChatGPT. Where are you, man? Oops, not this. Okay. So because our screen is landscape, we want some change to our calculations so that we'll get like an oval shape, not a circle, right? So we can fit more chicken there. So change this line to this line. Ah, okay. So we get the higher x like this. Okay, makes sense. And then we have to normalize it because it will not be a unit vector anymore. Or let's do it here. Oval amount, or I don't know. Oval width to height ratio. Let's make it 2. 1.8. Shape. And we'll basically do this times that fellow and like this. And I mean, now let's do it like this. I mean, just to see all 3 components. Normalize. I mean, we do normalize it, but will it work the way we want? Because it will be always the same position. Yeah, so actually we shouldn't normalize it. Yeah, so it will be like the distance between the spawn point, and it will be the correct one when it will be at the top, and then when it moves towards the screen end, it will be like bigger than this distance. But it's fine. I mean, this is just theory. We have to see how it looks first. Yeah, let's see. Well, this, then it changes, and yeah, let's see how it works. I'm really curious, man. Really curious. Good. This is wave 2. Let's create wave 3, which we already have. We need a unit prefab, which will be a blue duck. Spawn interval, so 0.3. Total max units 50. Spawn point orbit center. Let's see basically where's our. Let's just create a small object so we can see where's our. Where's our. I mean, this thing should be like this, and let's just move the chickens. Oops, not this. Yeah. Okay. Okay. Good. And that's our wave 2, correct one. So we have like a 0, 0, and we don't care about like realigning it and all of that stuff. Just do it the right way, right from the start. Wait, guys, let me look. Where's the YouTube? Oh, okay, here's the YouTube live stream. Good. Let me put it back here. Come on, man. Good. Okay, wave 3. We know where it is. It'll be like here. It's like the 0. And we kind of want the spawn center to be higher a bit. And let's create the spawn center, which will be a sphere. Let's remove the collider, because that consumes resources, not too many, but you know. Let's have it like this. Let's make it smaller. And this will be our spawn center, and now we have like the spawn point. And this is like doesn't really matter because it will be, yeah, it doesn't really matter where it starts. But let's say like if it's here like at 250, 260, and we want it to start maybe here, so it's like 2.5, 2.6. Yeah, 2.6, right? 2.6. So that's the distance between these things, right? So we'll have like spawn point orbit center. Spawn point this thing, which really doesn't matter because the script automatically moves it. Spawn point orbit angular speed. So how many angles, how many degrees per second? So it would be, if it's 90 degrees per second, it would be like bam, 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 bam. Kind of, I think I like it. But let's do, like 45. I don't know. Yeah. And the spawn point, I don't know, let's make it even smaller. We can just disable its mesh renderer so we don't see it, but just so we can test things. Let's see it. And you know what? Let's give it like 49 units because we will be adding a green duck ourselves in the middle. Wait. Bam. And let's add near the spawn point. Yeah. And all of those guys will be spawning like this. Okay. Okay. Good. This is the wave 3. And let's say current spawn point distance. Let's like have it not spawn right into it. You know what? Let's make the green duck smaller. I just like smaller size. Oh, I think the visual has to be, or no, actually also the capsule collider. Yeah. Okay. And let's see, this is 2.6, and if we move it like, I mean, we have to spawn orbit center 2 point whatever, and the green duck, if it's like it's kind of, yeah, it's in the same place. Let's say if the second one spawns, we have to have it, want to have it like at least here. Right, so it's 1 meter, not even 1 meter, like 0.9, 0.87. Initial spawn point distance. And we'll have like current spawn point distance will be like initial spawn point distance. And we also like, let's yeah, initial whatever, and the maximum point distance, max spawn point distance. So we do it like this. Bigger than the maximum spawn point distance. If it's yeah, bigger than that, we are clamping it to that value. Good, and let's now check this here. So let's see, we have in the wave initial spawn point distance. So it's like 0.87 or something like that. And maximum spawn point distance would be so current spawn point distance is this thing. Yeah. And this would be like the maximum distance where the distance is the smallest here, because we'll also get it here because we're making the oval shape, right? But it refers to how far it will be the top and the bottom. So let's say our second duck will go like maximum here, let's say, and it's like 5.87. So from 2.6, like 2.6, 2.9, something like that. So 2.9, and we'll see. We'll see. Let's make it like 2.6 just to be sure. So the way we are imagining it is it will start like here, and it will like initially, if we have this like initial spawn point distance and maximum spawn point distance, if we have them at the same number, right, we will just have this oval shape like this. They will just spawn here. But if we make it increase, it will go like this sphere, something like this, right? And we'll see. I mean, we'll see. Good. Man, let's try it. Yeah, it's something. It's something, man. It's something. These things are pretty powerful. And yeah, they stay in the same place, so of course we can make them like move a little. Yeah, I like it. I like it. We can just make them spawn. Wow, so it worked like right from the beginning. The first try. 0.6. Yeah. And actually this is the blue one. Yeah, right. It has to be a blue duck. Bam. Spawn point. Blue duck. I mean, you can put it in the spawn point, have it like 0, and then put it back. And now it's in the same place as the spawn point. Oh, orbit center actually I wanted. Reset. Actually, no, because it also changes its scale. Revert. Yeah, let's just... Okay. And let's also, like, I just like it, angular speed minus 45. So it will go like this. Wow, you know what? But no, you cannot do that. I wanted to like make the spawn point be a duck itself, but it doesn't work like that. It doesn't work like that because if you destroy it, then you don't have a spawn point anymore. Yeah, so that's your like third wave. And of course, like ducks are being spawned one inside another, but it's fine. Okay, we have our third wave. And let's see, is it satisfactory? Yeah, it kind of works the way I want it. Yeah, I mean, it's fine. Good, and I don't know, there's a problem where it spawns one there, the first frame. I mean, we can just cheat a bit and let's just move it here or somewhere like that. Yeah, like here. There's something with it, I don't know if I should go into the code and... Oh, I know what it does. So, yeah, it spawns something before the first update is called. So let's do, what should we do? So we first have to do this thing once. So this actually belongs here because we're moving the spawn point. And actually we can do it here, I think, because we're using delta time. You know what? Let's actually do it here. Or yeah, it doesn't work like that exactly because we can use the delta time only inside an update. Here it's a bit more tricky. Yeah, it's more tricky. So we are doing this thing here, but we need to call it at least once. So let's call it at least once here. And yeah, we can have like our spawn point, doesn't matter where. Yeah, so we first update our spawn point. You see, right? So it works the way we wanted. It creates two ducks in the same position, but it's fine. Yeah, okay. Looks good for me. So wave 3. So let's now go to level 1 and we have these things. So let's see, can I do 3 prefabs? Yeah. So okay, but I have to uncheck them. This one, then wave 2 is this one, and then wave 3 is this one. Nice. Yeah, we have now 3 waves. Okay, so we have our waves. Let's go back to the design document. So we have this one. And we have a wave, but the waves also have names. Astonishment phase. Okay. Oh, one overgrown duck in the middle. Okay, now I get it. That's how it will work. Um, yeah, let's create our overgrown duck. Where is it? Overgrown duck. Overgrown duck. So it's just an overgrown duck. So it's a bigger duck and it has an HP of 300. Let's create it. I mean, it's so easy since we've created the building blocks and now we can have any number of ducks and types of ducks. Overgrown duck. Overgrown duck. And this one is bigger. And now we go directly into the wave3 asset and we can do it from here. So instead of, so we have 50 still, but we'll have the overgrown duck in the middle. So like this. Yeah. That's it, that's our overgrown duck. Okay, maximum health is 30. Yeah, we have to apply it to the overgrown duck prefab. Apply to overgrown duck prefab so that it's here. 30, right? So this is the prefab that's used inside the wave 3 prefab, right? So if this thing changes from here, like we change something here, it will also change here in the third wave prefab. You see it changed here. That's the power of prefabs, and you can nest them by how many levels you want. Okay, so now we have our overgrown duck as well, and we can where is it? Okay, and our wave now. Where's our wave? Yeah, so we've done all of the waves, but also we want to give them names. So let's have like a wave, create. Where are you, man? Something happened. Create C# script wave. Pretty simple. Wave, perfect. Wave, and it has a serialized field, string name. I think there's might be a conflict between the name property of the mono behavior and the name of this one, but or actually let's call it like title anyway, because it's not like the name, it's the description. Good, title. And that's it. Yeah, just the title. And I mean, let's expose it. Because there will be like a wave manager, and we'll just see now. Wave manager. And the wave manager is very, very simple. So wave manager has a reference to yeah. let's do it like this first. And we need our, where are you? Duck invaders. Assembly definition to reference the text mesh pro assembly definition. So assembly definition. So we'll be able to reference text mesh pro. So we'll be able to reference it from code, the text mesh pros components. This is the component for the text in Unity. So it was text at first, but then it has been upgraded a few years ago to this component, which is like very powerful. Yeah, and we have a wave manager which has the waves, right? Or let's have it like the wave will have delay, start delay, right? And it kind of tries, it starts to make sense, right? So you have your waves, and you have the wave title, and you have, let's say, so the wave manager needs to know when did everyone, yeah, when did every unit of this wave die? Like when there's no more units to spawn. And we'll have like, or bool is done. And it will be abstract because the class itself will be abstract. Or actually, no, I think we can just keep it as a base wave. Yeah. So we'll have like each wave will have its ducks stored in an array, and then when all of the objects in that array are are destroyed, then yeah, we basically return to true here. So let's see how we do this. You know what? No, it makes sense to do it this way. Oops. Because we'll have a base wave anyway. So the wave, oh, the wave has to be here in the base wave. And now we have our simple wave. Or predefined wave. Predefined wave. So what that means is that it will try to get all of its initial ducks from the start. And let's see what does Inti have to say. Is done get, and it will be done when, so in start, what we'll do in start, actually let's add the start here. Okay, and we then override the start here. So when the wave starts, we get, okay, these are all of our, wait, man. Yeah, when the wave starts, it's actually not that. I mean, actually, no, actually makes sense. Yeah, makes sense. Yeah. So predefined wave. So when we start, we get all of our ducks. So base duck, remaining ducks. So this is a list, and we instantiate it here, so it will be an empty list. And then we do get components in children of type base duck. I think it should work like this. And yeah, it will give us an array. And you have to do it like this, add range ducks, because one is an array and one is a list. And an array is this base duck with 2 square brackets. That means that it's a type of list which you cannot modify, whose size you cannot modify, but a list you can modify. Good, so remaining ducks, and is done if remaining ducks dot count is 0, right? It's done, and the wave manager will constantly ask, okay, are you done, are you done, are you done? Yeah, and we'll have a current wave, and we'll do like, oh, not start, update. So in update, let's say, actually we'll have current wave index, and current wave will be a property. And current wave index should be like -1, right? And we in update we'll do like check check or check wave, check advance wave. Hello again. Check advance wave, generate method. And let's see, so if our current wave is -1, it means we are in our first wave. Or actually, let's last wave end. So we know when the last wave ended. And we have this, because all starts are always called before all of our updates. We do it, we check it here. So when the game first starts, we said, okay, the last wave ended at the current time. So when the game starts, even there was no wave, but we need this. So when we would calculate how much should we wait until we start the first wave by using this start delay. And basically we will be using the same code also, like when the first wave ends, we'll be setting this thing somewhere here. And yeah, then the second wave will wait for us to start. And we can even do it like this, void mean, yeah, it kind of, no, I don't like it because it might appear weird if we put here mark wave ended. So yeah, last wave end, good. If current wave index is -1, then we start next wave. Yeah, let's do it like this. So start next wave is false, but if this is true, we start next wave. Else, and I mean, let's do it like this. If we already have a current wave, let's take the current wave. I mean, it should be like this. If current wave dot is done, then destroy the current wave. And if we increment the current wave, and if the current wave is equal, so what does this signify? Level done, or actually, yeah, we can have our boss to be just a wave, and it's a special kind of wave. And the wave takes care about the HP bar and everything, and the wave manager just sees it as a wave, and it's a nice clean way of doing it. Yeah, I kind of like that. So level done. If the current wave index reached basically our the number of waves. So if level done, then wave title, and also like let's have level title. But actually, you know, it's kind of, you know, maybe we have two of them. If level done, level title dot text equals, I mean, let's make someone else handle the wave, because I'm managing the waves, wave manager, but someone else manages the level. So I'm just doing my job. I'm not trying to be to overreach and outreach outside of that. And let's make just an event here, like, or finished. This will be the event, and somebody else just listens to our event and does whatever they want. So we are more explicit here, like just the way it's finished. We don't know anything else, so we don't know if the level ends here or if we show like a cinematic or I don't know, something. Waves finished, and we're done. We're done, and we do return, right? Otherwise, start next equals true. I mean, I think there's a better way of doing it. So if current wave index is greater than -1, you can do something. I mean, but let's keep it like this. Yeah. I mean, yeah, so we don't need this thing. So if the current wave index is -1, then we will be doing the spawning here. But if it's not, so it's not -1, so it's not, you know what? let's be more explicit. So or game first wave not spawned, and we'll do it like this. So if the first wave, yeah, it has to be with more like if game just started. So if the game didn't just start, we do this. So if the game didn't just start, so we are in our first wave or second wave or so on, and the current wave, if the current wave is done, then we are destroying it, incrementing it, and we check if all of the waves finished. All waves finished. If all waves finished, then we return. Okay, if the current wave is not done, then we return. That's it. So we are still, you know, inside the wave, so nothing to do. You see what I'm doing? I'm decreasing what's called cognitive complexity. So you try to not have too many ifs, too many stuff, and use these things like a lot of returners, and just make it more flat, flatter. So yeah, so if the game didn't just start, yeah, it's not that explicit here. Actually, let's do it like this. So if the current wave index is higher than -1, so the first wave has already spawned. Okay. And if the current wave is not done, just don't care about it. But if the current wave is done, advance to the next wave, or at least destroy the current wave, increase the current wave index, and check, okay, is there any more wave left? If not, then do this, right? And if not, then continue execution. And here we also reach it when the first wave did not already spawn. And let's spawn next wave. I mean, to keep it really simple, it might appear maybe frustrating if you're looking at this, but it really helps you 1 month after you, like in 1 month from now on, it will really help you to just write explicit stuff here, like if first wave not spawned, spawn next wave, return, and that's it. If the first wave has already spawned, then we don't need to do it like this. And you see, when you decrement the indent, by the way, you do it with tab or shift tab. I mean, yeah, if you're an absolute beginner, maybe you don't know that. But you see, the moment you do it like this, you have already flattened it and decreased the cognitive complexity. So yeah, if the current wave is not done, nothing to do here. But if it's done, destroy the current wave and current wave index incremented by 1. Then we see if there are any more waves left. If not, we inform whoever's interested in that. We are done. But if there are waves left, then we spawn the next wave. And when we spawn the next wave, we basically yeah, there's a thing here. So you have to do this thing twice here. So spawn the next wave. Yeah, we'll not be incrementing it here. We'll be incrementing it here, which means we have to check, okay, if the current wave index is wavelength -1, right? That's the last index. If we have 5 waves, it goes from 0, 1, 2, 3, 4. 5 waves, right? Good. So we're doing this, and then we are doing a current wave. Yeah, actually, these are the waves prefabs. Wave prefabs, which means we need like the current wave prefab or something, right? Yeah, and now we have the actual current wave, which will be always an instance. Yeah. Yeah, so we have the prefab. So if the current wave, in this case, we can just do this thing, which is simpler, right? Current wave equals null. Can we do that? No, it's like this because you might have a current wave which is null. So current wave, if it's not done, okay, return. Then destroy current wave that object and set current wave to null. Then always finished. Wave prefabs, okay, finished. And actually at this point we want to start counting because each wave has a delay. So we will start, you see, like we can have basically our wave manager should be a state machine, right? Because we are in yeah, we should really have like a state machine. Yeah, we'll see about that. Like the wave, you have the initial wave, then the wave is playing, then the delay waiting for the next wave, and then again the next, you're entering the wave is playing part. Yeah, check advanced wave. Current wave would be null here. Yeah, let's make the standard wave of way of creating a state machine. So this is how you do it. So you just create enum. So for simple stuff like this, just use an enum. So that's how you usually do it. So this is a good convention to write e state. So you have init, then delay, start delay, then init, wait for wave start delay, wave running. And it's actually the wave itself should have If I'm thinking about it, yeah, the start delay is in the wave itself, so the wave should take care of it, of starting its thing. But no, this is the good way. This is the way, yeah, because some wave are already spawned. So when you instantiate the wave, the predefined wave, yeah, it's already there. So we have to actually delay the instantiation itself. So in it, wait for wave start delay and wave running. And our first state is init. Good. And actually here we are just waiting for init. So if, yeah, we'll actually do it here. Switch state case state.init. If we are in the init state, we'll just do current wave index is 0, and we'll be waiting for a delay, right? We'll be entering. Yeah, we're not spawning it. We're entering in the like first wave, but we're not spawning it. And yeah, we'll do, that's how you use it. So after each case you do right break, and you do state equals wait for wave start delay. And then also you have when the state is wait for start delay. Yeah, and let's say also we have start delay remaining, and we are setting basically this and the current wave prefab. So the prefab itself also gives us like the start delay, so we don't necessarily need to instantiate the prefab to get its properties, and we can do current wave prefab dot start delay. Start delay. Oh, okay, we have to expose it. I mean, start delay. And actually, I think these things have to be first. Abstract things are first, I think. Yeah. So, start delay remaining. So we're setting how much time is remaining until we actually can start the wave. And what we're doing here, so we're doing break means like, okay, just finish the execution of that date, and then in the next frame, you enter again here, and you will be in the state, right? Because we're setting it here, so the state will be equal to this. So it enters here, and we do start delay remaining. So basically, we are subtracting the frame duration from the start delay remaining, which is perfect. And then we do if start delay remaining is less than or equal to 0, basically, then we do state equals running. I mean, we have to spawn we have to spawn the wave also. And yeah, we'll do it like this. Let's just don't care, we just spawn it. So we already have it like this. We have the prefab, so spawn current wave, actually. Current wave. Spawn current wave. We have already waited for it. And we have state equals wave running. Okay. Works for me. And if the state is wave running, we'll just do this thing. If the current wave is done, this is how beautiful it is. You have everything here, and you know you have 3 defined states, and you know that you're always in one of these states. So if the current wave is done, then let's also do destroy current wave, or I mean, let's just have destroy wave, spawn wave, because it's obvious that it's the current wave. And I think even this thing, or no, let's keep it like that. No, okay, destroy wave. So we'll do this thing, right? If the current wave is done, destroy wave. And let's see what else here, like if all waves finished, so wave running is done, destroy all wave. And then we do this. If it's done, we destroy the wave, and then we check this, all waves finished. So if all waves finished, look, we actually have, we can add another state. All waves finished. And then we don't need a boolean, we don't need an event, or yeah, I don't know, let's keep an event as well. Yeah, state equals all waves finished, and we also call the event. So yeah, right. But if it's not finished, then we'll enter, we'll do current wave index plus plus. We can have like set next wave. We can have that thing, so we'll have prepare next wave, and we'll basically do this. So current wave index, wait, plus plus. So if it will be -1 first, it will go correctly to the 0 wave, zeroed, so the first wave. Then start delay, current wave, whatever, state is waiting for whatever. And we're just doing it here. Bam, prepare next wave. And guess what? We're also doing it here. Or yeah, let's do it like this, and then just change the state there. So all of our state changes happen here. And then we don't need this thing anymore. So first wave spawned, whatever, finished, spawn wave. We don't need that. And let's see, so we are at init first, so we start. Yeah, we don't even need this thing. So let's put the state first. Or yeah, here. We don't need this. We don't need the start anymore. So our current wave index is -1, and we are starting at the initial state, init state. So in the init state, we prepare the next wave, which means we increment the current wave index, which will go to 0, and then start delay remaining. It's current wave prefab dot start delay, and current wave prefab is again this thing, wave prefabs, in this the current wave index, right? So 0, the 0th position first, and then we enter the wait for move start delay. Yeah, and break. Then in the next frame we are checking here, start delay remaining minus equal, so we subtract the time that has passed since the last frame, and we're doing it a few times until the start delay remaining reaches 0 or below 0, and then we spawn the current wave, and then we enter the wave running state. So break, which means it doesn't execute the remaining of the code. And again, next frame we'll have wave running. We check, okay, is the current wave done? It's not done. So we're running, whatever, until it's done. And when it's done, we destroy the wave. And you can also do it like this. So if it's not done, or return if you want, like it really this, right? So it's now easier, right? So if the current wave is not done, then there's nothing for us to do. But if it's done, we destroy it, and then we check, are there any more waves? If there are no more waves, we enter the state always finished, inform whoever's interested in that, and just return. And I know what else happens. We don't care. We've done our job. If the waves didn't finish, we prepare the next wave. So again, it's like we're in the first init state. We go from index 0 to index 1. Then this will return the second wave here, and we get the current wave prefab would be the second wave. So this start delay would be its own delay. And yeah, prepare the next wave, and we enter again into the wait for wave start delay. So you see, all nice, like it's very this is a finite state machine, right? And it's a bit easier, and it's a faster way of doing it. Yeah, and if you don't think it will get much more complex than this is really like, it's perfect for this. Okay, let me switch on lights. Perfect. All right. So what else? So when we prepare the next wave, we have the wave title. And yeah, let's do it here. So prepare the next wave. So we set the title text. So current wave prefab.title. Incoming. Yeah. We can also have it like we can have like the title, and we can have like this is like the character for a new line, and you can also just press enter so that you can also like visually see it in code for a new line. But you can write it here like this, and it's not like a new line, right? It will be this, and then in the continuation similar to this, right? But just for the visual aspect, it really helps. Like you have the new line character. Yeah, so there are two characters which define the new line character. You have to write it like that. And you have like incoming. Right, and you can make it italics, or actually the title should be italics, right? Oops. Incoming. Yeah, that's the title. And we have to enable the title, because we'll be disabling it when the wave actually starts, right? So when we enter this state, so when we spawn the wave, which we're not doing it. Oh, the most important part. So we'll be doing like current wave equals instantiate current wave prefab dot game object again. And you'll be messing this up a number of times, so don't worry. You have to instantiate the game object actually. So the current wave is game object dot get component wave. So we're instantiating the wave, and it should be already instantiated at 0, 0, 0 position, because the prefabs where we made sure they are at 0, 0, 0 position. But you know, just to not waste time, just do it like this. Just center it here anyway. So it's at the origin. Current wave is this. Wave title is we deactivated. Yeah. Man, let's see what we've done. So create empty wave manager. And yeah, we need a canvas. Bam, we have our canvas. This is like a reflex by now. So scale with screen size, and I'm doing like this. And I don't know. I'm just keeping it like this because I always use it like this, and I just don't want to. So yeah, somebody said like this would be like the best, like more. It would make more sense. So the reference resolution to be like this. And I agree, if I would have time, I would experiment with it, but since this always worked for me, I'll just keep it like this. Canvas, screen space, all good, and let's create just a title. Text Mesh Pro, yeah, import TMP Essentials. This is the first time you'll see this thing for Text Mesh Pro, because it added this thing here. And you can add some emojis, stuff, and all of that. You can add your own, and yeah, you can add your own emojis and all that. Wave title. Is the wave title not in the middle, or is player not in the middle? Oh, okay, actually it is, but the alignment was off. So this would be like this, and we can make it bold. And yeah, like we can make it a bit transparent. Wow, I would really like a fade in animation. I would really like that, because it's so low effort but high impact, right? And I think you can do it in code. Man, I would really like that. Let's do it. Let's do it. So the way you do it is fade, crossfade, color. I think yeah, I think it's crossfade alpha, but it didn't work that much. So crossfade alpha, prepare next wave 0. Prepare, oh no, when we prepare it, we need like 0.7. And duration 1.5. Don't worry about that, it's not that important now. And in that case, we won't be activating and deactivating the text. It will always be activated. It will only have like an alpha of 0 or 0.7. And when we spawn the wave, we crossfade alpha to 0, basically. And we'll make it in less seconds, so like 0.5. Yeah, 0.5. So it starts slower, and then when the wave starts, the text fades faster. And if not, you would have to use crossfade color, but it's the same thing. So yeah, something like this, and it should be fine. Let's give all of our waves a name. So we have wave, which is abstract, and we have a predefined wave, which inherits from wave. And this wave has to also inherit from wave, which means it has to implement this if it's done. And it's done when, okay, and this thing like hides the inherited member, so we have to write it as an override. And also be good citizens and call the base. And I mean, it's not even about being a good citizen, you have to do it, otherwise your program is broken. It's not a guideline, it's just your program is broken if you don't do this usually. So we are done, and we even like check it here somewhere, I think. If the current unit count is smaller than maximum units count, and we are just adding it here. And just to not duplicate the logic, because this is always true, we shouldn't duplicate it, so we are checking it here. So while it's not done, yeah, and it's not done, okay, it's done when this is this, yeah, so the current unit count is this. Okay, I mean, it's done. And also you would need your other predefined existing enemies. So if that's I'll have to see how will we do this. Yeah, maybe like this. So like our predefined, oh, not enemies, units. Our predefined units dead for each it's not null, return false. So we go through all the existing units, or actually, because we have our overgrown duck, remember? So and you know what? Actually, these things are different. Now I get it. So if the current unit count is the same as the maximum unit, total units count. So that's what we are doing here. So we are spawning as long as not all units have spawned. And yeah, so what will we do now? Do we have a reference to all of the units that we spawn? Yeah, we don't have, but now we will. So manually spawned units. The fields should be after the properties. So yeah, we'll have enemy, or actually a list, because it's resizable. So we have a reference to all of our units. Unit prefab. Oh, you see, we did the mistake here. We instantiate the enemy instead of its game object. Spawned unit, yeah. Spawned units should be get component enemy. So this should be spawned units. And we don't need this thing anymore because now this thing, yeah, this thing is counts stuff for us. Current unit count, which is spawned units count, which is here. And of course, is done is now more nuanced. So if it's done, if you know what, we need a function for this. So we need like a question here. So all units spawned yeah, not very creative, but because there are more code, so enough code to write here, we'll do it here, not there, to pollute the properties section. And so the wave is done if all units have spawned. Basically, if all units didn't spawn, the wave is not done. But if all units did spawn, then we go through, we don't need this. We go through, let's say, where did we do that thing? Move spawn points, spawn units. Are predefined units dead? If the predefined units are not dead, then we're not done. But if predefined units are dead, then let's check. Are all are manually spawned units dead? And they are here, spawned units. And this is a trick for Unity, and I will see. I'll say later about it. Yeah, so if not, if manually spawned units are not dead, then return false. Otherwise, we're done. And the way it works, you see that we're adding stuff to this list, right? When we're spawning here, but we're not actually doing at some point like this at position 2 equals null. And usually this is the only way an instance would get null in C#. But in Unity there's a trick where you can overwrite the meaning of null, and basically Unity can make the C# runtime evaluate this thing as null, even though like in the pure C# meaning this value, it's not null, right? It's actually, you see, Unity engine.object.operator not equals. Basically this operator is like a shorthand for not equal unit null. This is exactly the same thing as calling something. Imagine this thing worked, existed, right? And that's what this operator does, and every operator in the C# language. And you see, it's Unity's own not null operator, or not operator, not equals, because you can compare this object with this object, right? But if you do like string x equals this, if you do x not equals null, let's say, this thing is, you see, bool string operator, so it's the not null operator of the string class. And yeah, like that's like the real not null operator, let's say. So, and a unity object becomes null when you call destroy on it. Like this. Yeah, you can destroy a component, which means it's exactly like right clicking and pressing remove component in the inspector in Unity. And you'd usually destroy the game object, not only the component, right? But in both cases, this thing would evaluate to false, right? This string would evaluate to true after you do this. And it should work. It should work. Last time I checked, it kind of worked. Yeah. Okay. Good. So if's wave done. Is wave done, and it works here. And the wave checks, okay, if we are done, then whatever. Yeah. And I have to remember how, why was I looking at this? Wave title, canvas, wave manager. And I think somehow like a wave manager needs a reference to the wave title. And if we will be making the wave manager into a prefab, but we don't have to, because the wave manager is tied to the level, so we will be keeping it in the scene. We shouldn't like create a prefab for everything. Wave title, bam. And let's add our waves again. Lock, select our waves, bam. Wait, didn't work? Okay, that's strange. That's strange. Why didn't it work? Oh, because we didn't add the yeah, we didn't add the base wave script to it. Wave, a predefined wave, and the predefined wave is okay. This already does some stuff. Yeah. Okay. I mean, we can also make it here because it's easier that way. So that this predefined units, we can just to prevent further like future issues, we can do it like this as well. So that if you add more predefined units, you will not maybe, and you forget to add them here as well. Like you create them, but you forget to add them in inspector to this thing, right? And it will give you issues, and it's not very like it kind of takes some frames, but I don't know, for a small game like it really, I really like it this way. So because it prevents issues and time spent, and time is money. So yeah, basically we will have a predefined unit, but we will add it here. Yeah, our predefined units would be this. Get components in children. So it will get all of the components on all of the objects, you know, and that are descendants of this object. Good, we're done. And wave one, let's add the predefined wave. Start delay. So the first wave, let's say it starts in 2 seconds. Title is, it has a title. Discovery. Man, I really, I kind of like it. Quite more than I thought I would like it. So let's say start delay. Is there a start delay? Oh, it was like a feature creep that I've created, so I shouldn't have added a start delay, but it's yeah, I don't know. It's too nice to not add it. Start delay, maybe again 2, and this is mutation phase. And this thing start delay is, let's say, like 3, because it's it builds up a bit. Yeah. Astonishment phase. Astonishment phase. Yeah. Good, so we have our wave manager. Again, lock. Select all these guys, put them here. Bam. And it's nice, you also see the type of the wave here. Like wave first is a predefined wave, which means the objects are already spawned, and this one is a custom wave, which has a script. Good. The event system is the thing that handles the input for canvas. So canvas again is for 2D objects, right? So you can create the buttons, and you can have your buttons to like where you can press this thing and your space can move to the left and so on. But on if we will have time on the mobile, we'll just be taking the spaceship and move it around, right? And yeah, that's how we will be doing it. Good. Okay. Wave, moving background. So that's our level 1. And we have a wave manager. Man, this is quite interesting. Yeah, let's see. Is there anything we should cross here? You know what? Let's add a puff. Let's add a puff. Because it's so simple. So we have our enemy, our base duck. Undied. And we'll turn this into... So undied, when an enemy dies, and we are a duck. And there's the thing when we are talking about, there are 2 phases for an object, like when the object is born and when the object dies, right? Or constructed, deconstructed, whatever. When it's constructed, we call the base first and then do our thing, right? It's like creating, I don't know, a house. It has to create its base stuff and then you add stuff to it. But when you demolish it, you do it the other way around. You first demolish the stuff that's outside and everything. Or no, you first like get out all of your stuff and then you demolish it. So it's kind of makes sense, right? So you first delete the stuff or manage your state here in the most derived class, and then you call your base class's functionality. So the base stack will have a particle system, game object, that event, that effect, and also that effect time, I guess. I mean, you know, let's add something which will be very simple to add. Destroy delayed destroy. Very simple. What this thing does, so when it's attached to an object, it will only call destroy game object, so this game object, and T will be delay. And that's it. That's our delay destroy. Delay to destroy. Wait. Yeah, it's good. That effect. And on that, we'll just instantiate our yeah, we'll just instantiate our that effect prefab. That's it. We don't care about it. And yeah, instantiate it. Let's instantiate it in our position. Right? Good. So our duck will, when our duck dies, there will be an effect, and each duck chooses its own effect. Good. Let's say like, where is it? Enemy base duck, or let's create it here. Effects, particle system. That base duck, or base duck that, and particles would be like just 2 or something, and it will not be looping, and the duration would be like 0.5, 0.5, and it will be bigger. Yeah, we need like some tinkering for it. Like it would be like speed over time. Where is it? Velocity over lifetime. Velocity over lifetime. So we'll need it like linear, radial, speed modifier, velocity over lifetime. Curve. Yeah, that's what I want. So Z, nothing with Z. Oh, not velocity, speed over lifetime. That's what I want. Where is it, man? Speed. Size by speed. Man. Is that not start size, start speed, start lifetime, simulation speed, scaling mode? Yeah, I'll have to see, like maybe the shape, something about the shape. Position, rotation, scale, velocity over lifetime, limit velocity over lifetime, speed. This be it, maybe? Like curve. I think this might be it, actually. Not this. Speed. Okay, I can see it. I can see it. Constant. So speed, start size, start speed, like 50. Okay, perfect. I like this. And we'll have to just do it in all directions, and the shape would be not a cone, but a sphere, I think. And you will have a mission that have, I don't know, rate over time. Oh, okay, max particles like 10. Yeah. And this would be like 10. But you have like, you have to stop it a bit at some point and to not loop. Yeah, you'd want all of them to start somehow. Um, how should we do that? So the duration is 0.5 and emission is 10 and max particle is 10 and start speed is this. Stop action, cooling mode, rate over distance, nope. So this is our shape, is radius, arc, mode. Position, rotation, scale, align to direction. I mean, this would be the effect, but I think we should make the speed, our speed. Wait, I just added the start speed. Oh, okay. Maybe this thing has something to do with it. But like 100 speed, isn't it like a lot? Oh, whoa, wait, no. Okay. Still, 50 is good. But max particles. Oh, there's a thing like burst somewhere here. Inherit. Yeah, but I really have to think to look into it, and this would be too much, I think. Burst. Yeah, no time for that. Uh, yeah, you have to really play with this thing. Instead, at least we can do this thing. So, curve. Inverse. Inversely, I wanted to just start from that thing and go to this thing. Right click and auto. And actually, I want this way. So this would be the size. Right. Let's see. Oh, okay, I see. I don't want it to be this dramatic. Okay, let's see. Then color over lifetime. We'll just fade it. Yeah, I just want it to be faster somehow. So limit velocity over lifetime. Speed. The speed limit of particle over the particle lifetime. Wow. Okay. I mean, no. Yeah, let's just do the rate over time. I don't know, 5. Maximum number of particles 5. I mean, it works for me for now. I just want to like, bam, right? To have like that high initial speed, and I didn't velocity over lifetime. And this should be like constant, but it's for everything. But I don't want the velocity. I want the speed. Start speed. The start speed of the particle applied to the starting. Okay, and this is like 50, but then shape velocity over lifetime. This is velocity, here's velocity. Lifetime by emitter speed, force or lifetime not. Color by speed. Size or lifetime. Size by speed, no. Interesting. Okay. Yeah. I mean, it looks fine for now. Good. So base duck death. We have an enemy, and our blue duck will have a death effect prefab, and our green duck as well will have a base duck death. And our overgrown duck, yellow duck. I mean, you can't not do it, right? So overgrown duck death. You just can't not do it. I mean, yeah, you cannot really be dark like that. So overgrown duck is what? It's this red, okay. Yeah, you have like to do it like this. And you'll sorry, you'll be making bigger. So start size 10. Yeah. I mean, first time it worked really well. Oh, it works better now. I mean, but if we do like 10. Okay. Okay, now I see it. So max particle 5. I mean, maybe 1. Interesting. Okay. Start speed, start size. Okay, let's apply all of these things. here, apply to the prefab, right? And that's also so 100 and here, what did we have there? 0 and 0.3. If it's 1. I actually like this one. 0.8. Okay, but it's kind of, I think I need the simulation speed to be faster. Yeah, I need the simulation speed to be faster, like 10. Yeah, and duration to be 10, something like that. Yeah. Oh, actually no. Simulation speed 10. Start lifetime 10. Ah. Okay. 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 Now I get it. So 2 and 2. 3 and 3. So now I get it. Not quite, but still a lot. Let's do like copy component and then again put it here. And we'll be setting like the color. And the size will be 10 for this one. Good. And again, apply. Yeah, so now we have the overgrown duck also has its own death thing. Good, then we have level 1. I mean, let's just see what happens. Let's see what happens. Oh, so big. Base duck death, it's like 1-1. And okay, I think the effect has to be smaller. But why? I mean, let's like go like this. Oh, I just think I just set the yeah, it's just I didn't have the scale there exactly. So yeah, and also the text I think is too big. Should it be here? What, or is here? Yeah, something like that. And we also have to anchor it. Press T for the rect transform tool, and we put the anchor to the top so that if our screen gets smaller or whatever, it still stays there. Good, that's our text, and let's make it smaller, like 25. Yeah. Good. Good, good, good. And I think it has to start like this, if it didn't already. Let's also do it in code, just because we are good citizens. Wave manager, current wave, wave title. When we prepare the next wave, we set the wave alpha to 0, and then from 0 we go to 7. We just make sure, like, even if you maybe forgot to set it to 0 in here, It's like good practice, like to you shouldn't care like to set 0 from here and then code and yeah. Good. Title, canvas, and make the particle systems smaller. Where are you? Yeah. Base duck depth. Play. Oh, too big. Even this one I think is too big. Yeah, and now you have to basically have the speed like 10 or whatever. Yeah. Might even need to make it like 0.2 or 0.3. And have the speed like again like 3. 0.1. Oh, not side, speed 1. I mean 0.1. Okay, I think it doesn't really matter what speed you put there. So yeah, okay, 0.3, and it's fine. It's fine, I guess. Oh, also, the emission shape should be a circle. And it should be like, yeah, so this should be like this. So in the 0 position, and it should be like this. And you look at it like this. Yeah. Okay, good. The reason we do that is because when you instantiate it, you want to basically you are positioning it correctly, but when you're rotating it, it will just be instantiated like that, just already rotated. Okay, and let's also in the shape, let's make it a circle. Okay, yeah, and starting size, I don't know. Yeah, I think this is enough. I mean, we can also like add 6 of these so they can be more. First mission 6. Oh, this is burst. Yeah. Let's see. Count. Rate over time 0. Yeah, those are the bursts. But let's keep it our way. Okay. Good. So those are our fits. Wait, our text didn't appear. Okay, crossfade alpha. So I think when you prepare the next wave, this will not work. Okay. Crossfade color. Yeah, you have this thing color white, which is just a vector with 4 components, RGBA. right? And target color would be alpha equals 0.5, 0.7. And you get the duration and all the stuff. So this target color and how much? 1.5, 1.5f. And use alpha. True. Yeah. Man, I don't know. Should this, like, maybe it's because of this thing? Mm. Color clear is 000. So we're getting from 000 to this target color. And let's just delete this thing. So, and here we're going to the same thing, but we're doing so from what we are now towards color clear. And when you're doing it in a third of the time. Let's see. Yeah, in Unity, the crossfade color and crossfade alpha doesn't work that well, or at least crossfade alpha. I had some problems with it before. Man, I'd really like that thing to work. It's this, and yeah, it's just not working. Yeah, it just doesn't want to work. Okay, bummer. So man, I really have to Google this because it should have been low effort. Again. Asking ChatGPT for help. Come on, ChatGPT, are you so slow now? Okay, Cloud doesn't know me. I have to create a new. Don't go here. I need you here. Good. Let's see. There's no something that I don't know. I mean, it gives me my. It gives us a custom implementation for the fading. I mean, should we import the .twin package? I think they have a light version for it. I think it's time. Yeah, I think we'll have to use this package. So, and you will basically also see like a new nice thing addition to your asset database. Yeah, .twin, which now it's called hot twin, or it was hot twin before, I don't remember. And this guy is nice with us. He put it in plugins, which is nice. Dotwin is a very nice asset which allows you to animate stuff. I'm just asking Cloud, so how do I use Dotwin, because I forgot. Okay, it gave us the code. Let's see what the type, circle options, whatever, cannot be found. And I think this works this way because you read me. Okay, let's see. So tools, demigiant, and press setup.win. We don't have a tools because this thing, I know why it does that thing. It's because it doesn't have an assembly definition, I think. Is that it? So we have the modules. dg.twinning. Again, I'm asking Claude about this thing. Yeah, we can try that. So let's add an assembly definition for all our plugins folder. And that's it. Let's see, or we just can try. Oh, that was it. So yeah, add an assembly definition for a plugins folder. Yeah. .win setup required. So select setup.win in .win utility panel, set it up to add removes. Important case of upgrade. Okay, I don't care about update. Setup. Setup.win, add remove modules, create ASM def. Also, if you need to reference the extra .win modules, like let's create an ASM def. .win modules. Okay. Will you add it here? Or where did you add it? Yeah, probably add it here. Yeah. Okay, good. Okay, you're insisting. Preferences, yeah, lots of things there. I won't be going through them. Setup. Audio, physics, sprites. Okay. Good, we're done. Let's go into our duck invaders and add the .win as a reference. That's what we have to do. So we can see it in our code. Good, and now we'll be using just this simple code for twinning. And you can do a lot of things, like you can basically animate anything and set how fast it can move, and like how fast the animation should be, how long, and you can animate everything. But this is a more of a programmatic approach to animation, and more for like mostly one-shot animations where you press a button and something happens and you don't care, like tracking the animation, executing something when it ends, and so on and so forth. You can do that as well, but it's mostly for simple one-shot type, fire and forget type. Yeah, and we can do fade. Text component. Perfect. Perfect. Let's go in our code. Loading whatever. And we can do this fade. I mean, I have to implement it somehow, but I have to remember. Yeah, using dg.twinning. You have to manually like know that you have to use this using dg.twinning. Fade, do fade. And they've basically created the methods manually for every, like, this is the UI graphic class. So the title, the text mesh pro UI at some point has a descendant in its class hierarchy where it inherits from the graphic class. And .win package works on this graphic. So basically you get from end value and the duration. That's everything you need. So prepare next wave. We go to 0.7 and duration 1.5f. And we want to also set the alpha to 0, so it starts from 0. Right? And bam. Do fade. Did you find an assembly that you are not? You have to reference .win. Okay. Okay, let's do that. We cannot do it now, I think. You cannot do it here. You have to reference it here. Okay, it's not here. It's actually, it's an assembly itself, which is a DLL, and you have to reference it here. And if you're like a Windows developer or whatever, you see a DLL, but actually that code is compiled to every platform like Android and whatever. It's just in Unity here, that's a DLL. Good, do fade. Bam. And here, when we spawn the wave, we do from alpha 0.7, but it's already 0.7. So do fade, preparing to this. And then from 0.7, we do it for 0.5 seconds to 0f. It's already like not 0. So we're going from whatever value it has. So this towards 0. Okay, now we have a real game. You see, like you think something takes a little time, but it takes a lot of time. So we have to be careful with that. Yeah, discovery phase. And this is our level. Yeah. And I don't know, should I just destroy them manually somehow? I think I should somehow. I mean, if you want to test your level, you'd have to have some shortcuts, some yeah. So you see, there's a problem here in wave manager, and we have to go through the, if the wave is not done, we have to, I don't know, is it this one? Okay. How you basically can do right click and find all references, or it's like on Mac, it's command shift R. Oh man, why did you do that? Predefined wave. Oh, okay. So it's not like the count is 0, but actually you press tab to make that work, if you're wondering. So duck in remaining ducks. If duck is not null, so if at least one duck is not null, then return false. Not all ducks are dead. Predefined ducks. Yeah. Let's make it somehow. I think we can destroy them manually. Let's try that. I mean, let's make this bigger. And let's destroy some of them manually. We are cheating, right? That's the power of testing it in editor. Okay. Okay, man, we have waves and something went wrong. Let's see. Current wave prefab. Wave prefabs. And the wave manager. Let's see, can we see current wave in the, what is this? 1871. I think this is just an issue with, I think it's called multiple times. We'll see. Astonishment phase. Astonishment phase is after this one. This is a mutation phase and then astonishment. Okay, I think something happened, like it started the next wave immediately. So it started our so we are here in wave running. It's working, and then when we need to, when this is done, we destroy the wave, and then if all waves are finished, so the current wave is the last one, then we enter whatever, but then we prepare the next wave. So I think I shouldn't. Oh, okay. So if this was the last wave, then we're done. But then we prepare the next wave. Okay, so this goes to, yeah, this is less than the last wave. So this might be like at maximum is the last wave, or like 4 if we have 5 waves. And then we do start delay, whatever, text, do alpha, whatever. And then state is wait for start delay. And this is set current wave or start delay. And we're waiting for start delay. And okay. We're waiting for, so start delay remaining. We're waiting, and then we're spawning it and entering wave running. And this wave done, is wave done, it will be false. Let's go to, but yeah, it shouldn't, like, let's fix this, right? Let's see, I think this will just keep incrementing. Yeah. Let's debug it, right? So let's debug it, attach to Unity. So we'll go to wait for wave start delay, and we have this here. Enable debugging for this session. Okay, good. Okay, I think it entered. Come on, man, I don't want to here. Unity. It entered, yeah, it entered here, so we press F5 so we can spawn the wave. And let's remove a lot of these things. Maybe we caused it somehow. Punishment phase incoming. And now again. Spawn wave. So it spawns the wave. And we go like F11. No, okay, doesn't work with that. Or Mac F11. Okay. Current wave index is okay. This shouldn't be 2. Oh, okay. I see what it does. So when we're preparing the wave, we're already incrementing it. But when we're spawning, we should spawn the wave that we've already prepared. So we shouldn't like do it twice. Okay, good. Easy fix. Easy fix. Let's like detach and everything, and we're happy now. Or at least we're one bug less. One less bug closer to completing the first level, right? Wait, something. Okay, wave 1. Yeah, wave 1. And this is wave 1. Okay, now I see that actually the wave 1 is you can clear it faster because mutation phase. Yeah, and we have to add that delayed destroy on this effects. Remember, we created that component, but we haven't used it. Astonishment phase. Yeah, I really want. Okay, I destroyed that one. It was so yeah, it was faster than I imagined. But it wasn't that. It looked like the overgrown duck. Come on, man. Overgrown duck. I think the overgrown duck was too easy to kill. Wasn't that the case? Blue duck. Why is the blue? Oh, we're not parenting the blue duck to the wave. Okay. Good point. Overgrown duck. Your health is 300. Okay. Let's see. I shoot this, then I shoot this. Oh, okay. I see. Yeah. 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 Okay. Base duck. Yeah, and just at this point, our wave manager calls this thing, right? And we now have like level manager. It's very simple. Let's make it, man. I mean, it's so simple. Famous last words. Level manager. And we need a reference to the wave manager. Sorry. Damn it. Good. Level manager has a wave reference to the wave manager, and in start we subscribe to its finished or whatever. And we have our first level minus the boss, basically. Level end title. Yeah. Level end title. We can hard code it, but let's just write it like this. So area cleared. Yeah. You can even do it like this, even though it's kind of redundant because you can already set it in Unity, but yeah, let's give it just for the sake of example. Okay. Good. So we have our level manager now, which is a very simple object. Level manager, and let's this back to normal. And text. Area cleared. This is the wave manager, and let's like get the level type or level title, level end title. We have it here, and level end title is bigger, right? This is smaller, and that is bigger. And maybe it's like this, and yeah, you know. Yeah, I don't know, like this, or no, just keep it simple. Yeah. There's this thing, design thing, that you should never have full whites in your game, or almost never. Like you should have it like this very, very subtle gray. Even this is like too dark. And it goes a long way. It's easier on the eyes, and it's nicer, and yeah, it's just more realistic because you don't have complete whites in the real life, right? Good. And that's the title and should be fine, I guess. And let's go to the effects. Overgrown duck death, and let's add it that destroy, delayed destroy, and let's destroy it in, I don't know, 1 second or something. Copy component, paste duck death, right click. I mean, you have to right click it on this thing here, like paste new component as new, and you see it here. So when we are spawning the effect, the death effect, we are also, this script just says, okay, I mean start, I will destroy the game object that I'm attached to after the delay seconds, which we configure here. And I think that's it, right? I mean, we can just go really fast, really quick through it. You know what? Incoming. I don't like this incoming. Just keep it simple. That's it. Yeah, that's our first level. Let's destroy some of the things here. Yeah, and we have to add that functionality for our chickens to lay eggs, right? Astonishment face. Yeah. There should be some kind of an effect when the projectile collides. That would like really be satisfying. Okay, we haven't set the... So the level end title, so our level manager didn't have this thing selected. Level end title. But I'm sure it works, right? I'm sure it works. I mean, you know what? Should we add that thing as well? Let's add that thing as well. When the projectile hits a particle system effect on it. Like it should be simple because we'll just use the same particle effect as when the chicken dies, the duck it dies. So weapons, laser projectile, and let's get where are those things? Enemy base duck death, and we have it here, and we'll call it laser projectile hit. And we can add some sounds in it, and but we'll see that later. Laser projectile hit, good. Let's just go with it here, and yeah, let's create it like this, and it should be just, I don't know, one probably. A smaller one should be smaller. Size 0.1. And speed should be maybe 1. .2. Okay, velocity, limit velocity over lifetime, speed. Oh yeah, I really like, we should go into the shape and have radius. Okay. And the duration maybe should be 2. Let's see, does it work like this? Duration, start lifetime 2. Let's also not make it the size over lifetime. Let's make it like this. So yeah, and also the number of particles 2. Yeah, okay. Does the laser projectile hit? And another thing that we forgot to do, we go here, which is not very important, but we should do it. Like when we spawn new units, we should spawn them, instantiate, but we should instantiate them as parent this transform. So the transform of the object that this script is attached to, right? So we are the wave object and we attach the units to ourselves. So we can see them better in the hierarchy, but it's also just good in general. So we've added that particle system, and we have in the projectile base, do we have the projectile here? We should have a projectile there. Let's put the projectile here. Okay. And the projectile should have like destroy effect, hit effect, game object, hit effect. Yeah, I mean, it could be maybe too specific for this one. Let's create it in the laser projectile. I mean, we can do this actually here. So that, yeah, we can do it here. So hit effect. And hit effect is when we destroy. I mean, no. It's still too specific because we might have like a projectile which is not like a bullet, but it's like a laser, a beam, laser beam, or, you know, like an infinite laser beam. Okay, and then we do instantiate hit effect game. I mean, it itself is a game object. Position. Yeah, so basically we are instantiating it at this position, at our position, and rotation identity, which means doesn't matter. It's the default rotation, but we have to specify it, and it's just redundant, but yeah, we have to specify it. And yeah, we are instantiating it at our current position, even though we are like dead, right? But let's actually instantiate it after, like before, like to have the destroy and the our game object have the last as the last instruction, because it kind of makes sense. It makes sense, yeah, to have our game object like this is the last thing you should execute as part of this object and nothing else. Yeah, and we have to also like add, sorry. um we also want to add this on this hit object to have that which we already have. Okay, good. And it's not looping. Okay. And laser projectile, hit effect, hit effect. Bam. Another thing is like we should check if this is not null. And this is another way of checking if a Unity object is not null. You simply write if that object. But it's just make sure that you're using like a Unity object for that. Meaning that a mono behavior or a game object, so it's not like a vector tree, even though it's like in Unity, but it's a struct. It's not like an object that uh, derives from Unity's own object type. Yeah, if hit effect, then instantiate hit effect. Because maybe you want like projectile which doesn't have a hit effect. I don't know. Okay, let's see. Okay, where are you? Still so many. Okay, I see the hit effects, but they are too small. Let's create an, and you see the beauty of it because you have your enemies, and you can literally just move it here. Bam, and it died, but I don't know why. I don't know why it died. Why does it die? Oh, this is the effect. Yeah, and they are too small. The size 0.6. And actually we want to spawn them at the hit point. And you see we apply damage, and we kind of would have liked to see the hit position, right? On collision enter. Yeah. How should we do this? I mean, we could even send it the collision. I mean, why not? Yeah, let's send it the collision. And it can be null. So we're sending the collision as well to this apply damage. Yeah, we have it in many places. And then in our laser projectile, we have the collision, and we then instantiate on the collision that game of contact points, contacts, first contact point, dot position or point. That's where we want to instantiate the hit effect, right? Yeah. And let's add an overgrown duck here. Or let's start the game and then add it. Overgrown duck. Yeah, you see, collisions, collisions. Okay, now it makes sense. Yeah, now it looks better. Rotation phase. Okay. Area cleared. Yeah, and now basically you can show a cinematic or something, and yeah, your player would just enter, go to the next level, and so on. Nice, man. We went overboard a bit, but I'm fine. I enjoyed it. Good guys. So see you next time. Thanks for joining, and yeah, have a nice evening or day or